Picture this. You're sitting in the exam hall for the Cambridge Information Technology 9626 paper. The clock is ticking down, the pressure is literally suffocating, and you're staring at a question that looks like an absolute gift. But in this specific exam, a single misunderstood word is all it takes to plunge your grade from the top band straight down to 0. So today, we're skipping all the basic fluff and exposing the hidden traps in secondary storage that routinely destroy marks. Here is the exact type of question that catches students completely off guard. Just read it carefully. Name 3 types of media used in secondary storage devices, and it's worth 3 marks. Take a second right now and answer this in your head. Got it? Seems incredibly straightforward, doesn't it? You just list the everyday tech we all use to store data, right? Well, here is a totally genuine student response to that exact question. Hard disk drive, CD/DVD writer/reader, and solid-state drive. Honestly, this looks perfectly logical. Yet, this specific answer scores exactly 0 marks, a complete and utter wipeout. 3 easy marks just gone in an instant. It's a kind of massive shock to your confidence that severely risks your grade boundaries. So we really need to ask, why on earth did this happen? Here is the fatal mistake. The student completely confused a storage medium with a storage device. And the examiner expects you to know this distinction inside and out. A storage medium is the actual physical material where the data, those literal ones and zeros, is held, like the CD itself. The storage device, on the other hand, is the hardware machinery required to read from or write to that medium, like the CD reader. So naming a device when the question specifically asked for a medium, that's the trap that costs you your grade. Okay, let's dive into this and make absolutely sure you never make that error. Remember, secondary storage is all the non-volatile storage that isn't part of primary memory. To truly master this part of the syllabus, you need a rock-solid understanding of the 3 distinct technologies it relies on: magnetic, optical, and solid state. We're going to break down exactly how they work so you have the precise vocabulary ready for the exam. Let's start things off with magnetic technology. Magnetic media rely on materials like iron oxide, where different magnetic signatures actually represent your binary data. A tiny read/write head acts as an induced magnet to either read or alter those signatures. Now, think about the massive difference in performance when we talk about magnetic tape. It actually has a very good data transfer rate, meaning once the data is finally found, it moves to the computer quickly. But, and this is a huge but, it has a notoriously slow data access time. Because it's literally a linear reel of plastic tape, the drive has to physically fast forward or rewind to find the specific data block. Moving on to optical media. These use lasers to read pits and lands on polycarbonated discs. Just compare the data specs here. CDs and DVDs use a red laser with a relatively longer wavelength. But Blu-ray, it's a whole different ballgame. It uses a blue laser with a much shorter wavelength of just 405 nanometers. And because that wavelength is shorter, the tracks of data can be squeezed incredibly close together, giving us a track pitch of just 0.30 micrometers. This super tight track pitch is exactly the reason why a single Blu-ray disc can hold at least 5 times the storage capacity of your standard DVD. In a moment, I'll show you the examiner clue that changes the grading outcome completely, but first, you need the framework that makes that clue obvious. Because simply memorizing how a blue laser works or what iron oxide does, that isn't going to be enough to push you into those top mark bands. You have to know exactly how to structure all that technical knowledge when you're faced with longer exam questions. So, let's see how this all builds into our ultimate exam strategy. For literally any question asking you to explain, analyze, or evaluate, you absolutely must use a structured framework. I highly recommend the PEELJ method. First, you state your point. Then you provide technical evidence. After that, you give a detailed explanation of how that evidence works. Crucially, you link it back to the specific context of the question. And finally, if the question requires it, you make a solid judgment. Let's look at solid-state storage so we can gather some really strong evidence to plug into our framework. Unlike magnetic or optical storage, solid-state technology has absolutely 0 moving parts. It's pretty amazing when you break down the microscopic architecture. It relies on a massive grid of transistors, specifically floating gate and control gate transistors. By applying very exact voltages across these gates, electrons flow through a tunnel oxide coating and get trapped in the floating gate, which creates a positive charge. This incredibly precise manipulation of electrons is what creates your pattern of ones and zeros. And it's because of that specific transistor grid architecture that solid-state drives, or SSDs, deliver such immense advantages over traditional hard disk drives. Right off the bat, they just don't suffer from latency, simply because there are no spinning plotters or moving mechanical arms you have to wait for. Furthermore, they are incredibly thin and lightweight, given that they're constructed entirely from tiny transistors. Beyond just the physical size, they run cool, use very low power, and still provide ridiculously fast data transfer rates. Plus, as a really unique feature, they allow for the permanent deletion of data, which is a massive security benefit when it's time to dispose of an old drive. All right, it's time for an interactive challenge. Here is a real 4-mark exam question. Explain why this medium, referring to solid state, has allowed development of smartphones, tablets, and thin laptop computers. I want you to pause this explainer right now. Take the technical evidence we just discussed about SSDs, run it through that PEELJ structural framework, and predict exactly what a top-band 4-mark answer would look like. Go ahead, take your time. Now, what's really interesting about comparing these two approaches is just how stark the difference is. The mark scheme heavily rewards applied knowledge over simple lists. Our low-level answer here just throws out some basic facts: low power consumption, big capacity, and low weight. But remember our framework. They completely miss the explanation and the link. The high-level answer, on the other hand, lists specific evidence: very thin, low power consumption, lightweight. But then it takes that crucial extra step. It links it directly to the devices mentioned in the prompt, stating this allows for smaller devices to be developed since they allow more components to be crammed into small spaces. And that, right there, is how you secure all 4 marks. The reality of Cambridge marking is incredibly strict. Just listen to these official examiner-style comments regarding the low-level response we saw. The second answer gets no marks since they have confused medium with device. Big capacity is just too vague to be worth any marks. Think about it. Saying something has a big capacity tells the examiner absolutely nothing about your actual technical understanding of the syllabus. You must be precise. Avoid vague language like the plague, use the correct technical vocabulary, and always answer the exact question being asked. So, you've now fixed your storage knowledge. You finally understand the fatal difference between a medium and a device. And you have a solid framework to build high-level answers. But what happens when your technical knowledge is absolutely perfect, yet you subtly misread the exam's command words, tanking your score anyway? Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. In our next explainer, Command Words That Decide the Mark Band, we're going to reveal the hidden cause behind dropped marks that even the top IT students completely miss. So, ask yourself before you sit down for your next paper, are you actually answering the question on the page, or just the one you desperately hope to see?